So this is the last video, picking up on number 34. It says factor completely, which means you're going to start by factoring with the first method of factoring that we learned, which is pulling out the GCF. So the question is, could you find the GCF? Well, you have 36, 54, and 18. It's hard to find the GCF if you don't have a calculator, but you could take a look at all three numbers and try to divide all three numbers by that 18, and you'll see that it does work. Okay? In other words, the 36, the 54, and the 18, you could pull out the common multiple of 18, right? 18 times 2 gives us 36. 18 times 3 or 4, 3 gives us 54, and 18 times 1 gives us 18. Normally, if you didn't have a calculator, you'd probably just pull out a 2 because they're all even numbers, and then you look at the inside of the parentheses and continue working on the inside of the parentheses. But because you could use a calculator, you should be able to see that there's a common multiple of 18 in all three terms. And as for the letters, there's j to the fourth right here, there's j to the ninth right here, and j to the fourth. So the maximum amount of j's you could pull out of all three terms is 4. So 18j to the fourth is your GCF. Now, you might be thinking, can I pull out k's? Well, you have a k here, 7 k's there, there's no k's there, so you cannot pull out a k. There is no k involved in the GCF. So what would be left on the inside? Again, 18 times what is 36? 18 times 2 is 36. And now how about the j to the fourth? J to the fourth times 1 is j to the fourth. You don't need to put it times 1. And then we also need a k up here, so I need to put a k down here. Now 18j to the fourth times what gets us a negative 54? Well, 18 times negative 3, and I did this on the calculator, 18 times negative 3 gives us negative 54, so I do have a minus 3. And the j to the fourth times what? Times how many more j's will get me to the j to the ninth? So tell me, guys, j to the fourth times how many more j's will get me j to the ninth? Yeah, 5 more j's. So you're going to have a j to the fifth right here. And obviously that k to the seventh, you need to put it in there because there's no other way of getting k's unless it's right there. Anyways, the last one, 18 times what gets us 18? 18 times 1. J to the fourth times what gets us j to the fourth? That would be a 1 also. So at the very end, you simply have a plus 1. And then you're supposed to check and see if you could do anything else on the inside, and no, there's nothing else to do. Do you guys understand that? Yes. Okay, now if you're still like, well, I don't know if I could find this 18. You guys want to see an alternate way of doing it? Okay, check this out, alternate way. The alternate way would be to say, okay, I know they're all even numbers, so they're all divisible by 2. So you could technically pull out a 2 if you wanted to. Oh, actually, let me do a 2 with the j to the fourth, because that's the not the GCF, but it's a common factor. So if you do pull out a 2j to the fourth times what will get you a 36j to the fourth k. Well, that's half of 36, which would be 18. And of course, you still have the k. And then 2j to the fourth times what middle term will get you the negative 54? Half of 54 is 27, so that's going to be a negative 27. And of course, that does have a j to the fifth and a k to the seventh. And then 2j to the fourth times the last one. 2j to the fourth times what gets you an 18j to the fourth? That would be a 9, and you don't need any more j's, so that's just a plus 9. So everybody's able to pull out a 2, right? Yes? Now the thing is, you could look at the inside, 18, 27, and 9. You could pull out something else. What could you pull out from 18, 27, and 9? 9. Right? So if you didn't have a calculator, this is the way I would do it. So I would now pull out a 9 from right here, here, and here. Pull out a 9. So check this out. If I put a 9 right here and I have the parentheses, what would be left over on the inside? I'd have the 2k. I'd have a minus 3, j to the fifth, k to the seventh, and I would have a plus 1, right? Okay, now what about that? What about this original 2j to the fourth I pulled out? Let's bring it down. That's 2 times j to the fourth, but you also have times 9. So you'd have to now multiply the 2 times 9 and get the 18, j to the fourth, parenthesis 2k minus 3, j to the fifth, k to the seventh, plus 1. As you could see, it's the same exact answer as we got up there. It's just a lot longer on doing it, but if you're not finding this greatest common factor with a calculator, you could just pull out what you know. You could pull out a 2 and then look at the inside and pull out whatever else you can, and then multiply whatever you pulled out. I hope that didn't confuse anybody. Let's move on to number 35. Simplify the product. Man, this one's ridiculously easy. Everybody should get this right. Why? Because it's just distribution. Yes, you have a binomial, but all you're doing is distributing one at a time. So let's begin with the 3c. 3c times 3c is 9c squared. And then 3c times 3, that's going to be a plus 9c. And now that you've already distributed this 3c, now let's distribute this minus 3. So I like circling when I distribute. Negative 3 times 3c is a negative 9c, and negative 3 times positive 3 is a negative 9. After distributing, you need to combine like terms. So when you go positive 9c with the negative 9c, what happens? Cancel out. They're done, right? They're out of there. So your final answer is 9c squared minus 9. Boom. That's it. Free points, I think. All right, number 36 is another easy one. It says find the vertex of this quadratic trinomial. It's definitely not in vertex form. I can't even change it to vertex form by putting parentheses around the x because there's another x over here. So I need to find the vertex using the vertex formula, x equals negative b over 2 times a. And let's use that formula the way we're supposed to by replacing any formula with any letters of a formula with the parentheses. Let's identify our a value is 1, our b value is negative 3, our c value is 2. We don't even care about 2 because c is not in the formula. Anyways, you have a negative 3 right in here and a 1 for a. So the minus minus changes to plus plus. You're going to end up with 3 over 2. And unfortunately, that is our x value of our vertex. Now remember, the vertex is a coordinate, and this first x value is 3/2. Or you could put 1.5, whatever you want. But the bottom line is that's your x value of your vertex. How do you find the y value once you already have your x value? Plug it in. So I need to plug in 3/2 into every x that I have, which is 2 of them. So let me rewrite my expression or my quadratic equation here. Blank or parentheses squared minus 3 times parentheses in place of x plus 2. And we are plugging in this x value of 3/2. So plug it in right there. Plug it in right there. Remember, this is not part of it, all right? It's not part of it. So let's simplify. And the beauty of the Casio calculator is you could type it in exactly the way it looks right here, hit equal, and it'll give you an answer. Check it out. There it is, exactly the way it looks on the calculator. Just type it right in, hit the equal button. It will give you the simplified reduced answer. It's beautiful. So the vertex is 3/2 for x, negative 1/4 for y. Again, vertex is 3/2 for x, negative 1/4 for y. Now, keep in mind, they might write this as 1.5, right, instead of 3/2, because 3 divided by 2 is really 1.5. So you could write it as 1.5 or 1.5, but this is your vertex. Let's move on. Number 37. Check this out. This is great because it doesn't have the instructions to just factor, right? I mean, you're supposed to factor, but it really says one of the factors of this quadratic trinomials is, so you need to actually factor it. You need to factor this quadratic trinomial that has an a value of 1. That's really easy to do. You set it up, parenthesis, 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 parenthesis with the x right there and there. And you simply think, what times what is your c value that if you combine together is your b value? You might want to make a list to help you out. How could you get negative 24? Negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6, and negative 5 doesn't work. So that's about all the possible ways of getting negative 24 besides changing signs. So you now go through and start combining and see which one gives you that middle value of negative 2. So if you combine these, you get 23. That's not 23. Combine these, that's 10. That's not 10. This is 5. When you combine negative 3 and 8, it's 5. That's not 5. This is negative 4 and 6. When you combine them, you get 2. Now this is a 2, but it's negative. That means I have the right numbers. I just have the wrong signs. So we should circle them, but change the signs. Make that a positive 4, make that a negative 6. So when you factor it, it's a positive 4 and a negative 6. Now notice that we don't see an answer that says like, oh, multiple choice A is this answer, right? We don't see that because they're not showing you the complete answer. They're just saying which one of these guys is one of these factors. So the x minus 8, that's not there. The x plus 3 is not there. The x minus 4 is not there. X minus 2 is not there. So it'd be none of the above. It'd be none of the above. Do we understand this question? Okay. When it says one of the factors, they don't want both, they just want one. Now, why are they doing this? Why don't they just give you the multiple choice A and give you that answer? Because if they did give you the answer, they wouldn't be able to test if you know how to factor. Because what could you do with this answer? You could distribute, combine like terms, and see if it actually gives you that. That's why they don't give you the complete answer. They're just asking for one of the factors of your answer. Okay? I hope that makes sense. Number 38, we have a quadratic trinomial equation, which is a parabola. It is opening down because the a value is negative. We will have to find the vertex. The vertex is a coordinate. In order to find that coordinate, we're going to use the formula x equals negative b over 2 times a. And when you use the formula, use parentheses, negative parentheses over 2 times parentheses. So our b value is 2, our a value is negative 1. So 2 for b, negative 1 for a. And let's reduce this fraction. You have a negative 2 over a negative 2. What is negative 2 divided by negative 2? That's positive 1. So the vertex x value is positive 1. Now we still need the y value. How do we do that? Plug it in. So I'm going to actually show my work here. I'm going to rewrite this equation, but with parentheses in place of x. That way I could plug in my 1. So there it is, negative parentheses squared plus 2 times parentheses plus 3 at the very end. And let me plug in the x value of 1 right in there. So when you go 1 squared, you get 1. When you go 2 times 1, you'll get 2. Let's not forget about this negative sign that's out here, though. You need to bring down that negative sign. So that's a negative 1. And 2 times 1 was positive 2, so you do have a plus between it. Bring down the plus 3 at the very end. What's your final answer for your y value of your vertex? What's negative 1 plus 2 plus 3? The answer is 4. That's right. So the vertex y value is 4. So we have the most important point, the vertex. There it is, 1, 4. Let's go to the coordinate 1 on the x, 1, 2, 3, 4 on the y. Put a dot right there. That's our vertex. That's step 1 of graphing a parabola in standard form. So we're going to, step 2, do the axis of symmetry. And we might as well state the equation of that axis of symmetry. What is the equation of that axis of symmetry? X equals the x value of your vertex, which is 1. And they probably will ask you that on the test, so be careful with that. Simply x equals the x value of your vertex. Now we need more points, so you could either go to an xy table, or you could use your pattern 1, 1, 2, 4, 3, 9. You don't even have to modify this pattern because the a value is negative 1. So the negative just means that it's going to be opening down. So you're still going to be able to use a pattern 1, 1, 2, 4, 3, 9. If you had a 2 right there, you'd have to multiply the 1, the 4, and the 9 all by 2. But since it's a 1, this is the pattern. You could just jump right into it. Here's your vertex. The 1, 1 is 1 over, 1 down. Let's put a dot there. And once again, I'm going down because the a value is negative. Go back to the vertex and do 2, 4. 2 over, 1, 2, 3, 4. Put a dot there. Go back to the vertex and go 3, 9. 1, 2, 3. And we have 4, 9 down here at the y value of negative 5. There it is. Map your coordinates over to the other side, right there, and right here. And that is our parabola. The only other thing we could state, actually there's a lot of things we could state about this parabola. For example, what's the domain? X equals all real numbers. How about the range? Y is less than or equal to the y value of your vertex, which happens to be 4. How about the y-intercept? Where does it cross the y-axis? Right here.
0, 3.
That's 0, 3, or you could just say 3. Yeah, you could use the coordinate 0, 3, or you could just say 3. What else could we say? How about x-intercepts? Do we have nice x-intercepts right here?
3 and -2. No, -1.
Negative 1 and 3. Yep, those are the 2 x-intercepts. Beautiful. All right, let's move on. Number 39. Easy one right here. Easy. The only thing that you have to worry about is distributing that minus sign, and then after that, you just think of money, right? You combine like terms. Q squares with Q squares, P's with P's, numbers with numbers, if you have any numbers, but we don't have any regular numbers. So anyways, distribute that minus sign first. This minus sign is going to make that q squared a negative q squared. The minus sign is going to make that negative 9p a positive 9p. The minus sign is going to make that positive 3p squared a negative 3p squared. All right, now there's nothing to distribute over here. So now it's just all about combining like terms. But you don't have this one anymore. This is your new modified trinomial over here. So you could just scratch out this top part because you already distributed the minus sign. Anyways, let's start with the highest exponent term. And what's the highest exponent? It's 2, the power of 2. So if you're faced with two different bases, let's go alphabetical order. Let's put the p first. So this is going to be your first term, negative 3p squared. And then go for your other squared term, which is q's, right? So how about the q's, the q squares? We have a negative q squared there and a negative 2q squared there. So we could actually combine those, and we're going to get a negative 3q squared. All right, so we've already used the negative 3p. We've already used this guy and this guy. What's left? We have p's and q's left. So let's start with the p's, alphabetical order. P is before q. So when I go 13p combined with 9 more p's, how much do I get? 22 p's. And at the very end, we're just going to slap on this missing value of minus q, and we're done. That is your answer. I do recommend to be very cautious when you're identifying your answer on the final exam with the multiple choices. Sometimes it has the exact perfect answer, and then they just change one sign, which they've caught me on a mistake already. I mean, it's easy math, but if you're rushing through it, you might make a mistake. Number 40, A and B, the last one. This is where we're simplifying square roots. And it's important to remember that a square root, maybe you want to jot down some notes right here on the side, a square root is the same thing as the power of 1/2. Okay? So even before beginning, we could split the root to each of the terms because there's multiplication between all of them, so you could split the root to all of them. You have the square root of 147, you have the square root of x to the 4th, you have the square root of y squared, you have the square root of z to the 7th. Now, let's simplify the square root of 147. And if you're confused about that, or if you're like, man, I don't know how to simplify the square root of 147, it's okay. You could use a calculator. Check it out. It's that easy. All you have to do is type in the square root and then type in 147, hit equal, and it'll give you the simplified square root. So the square root of 147 is really 7 square root of 3. Keep that in mind. So that's really a 7 times the square root of 3. Now, how about x, the square root of x to the 4th? We said that a square root is really the power of 1/2. So think about it this way. It's going to be x to the 4th to the power of 1/2. So when you have a power to a power, you multiply. So it's really like dividing 4 by 2, right? 4 times half. What's 4 times half? What's half of 4? 2. So I really end up with x squared, and there's no more square root. Okay, so we love having even powers on the inside of square roots. Why is that? Because it's simply dividing that even power by 2, and you get a nice, beautiful answer, no more square root. So how about this next one? What's this next one going to be? Y to the 1. No more square root. Now the last one is not an even power. And square roots are all about, if you don't have what you want, could you change it with multiplication to get what you want? And the answer is yes. I could change the z to the 7th. I could change to a z to the 6th times z to the 1. That way, when I split it, I could actually do the square root of z to the 6th. What is the square root of z to the 6th? Z to the 3. Z to the 3rd power. Okay? And we still have the square root of z to the 1. I'm just going to put the square root of z. So what's my answer? So far I have all of this in blue and this red square root of z. Now it's all multiplication, so I'm going to multiply all the nice values and put them on the outside, and I'm going to multiply the square roots and put them together on the inside of a square root. So my final answer here, guys, is going to be 7, that's 7, with an x squared y z to the 3rd, x squared y z to the 3rd, and then I'm going to put the square root of 3 combined with the square root of z, put them together underneath one square root. That'd be a 3z. And that's it. That's your answer. It might be looking difficult. All you need to do is practice. The more you practice, the easier it gets. Let's take a look at another one that's very similar to it. But this one is slightly different because it has roots that are separated. Okay? So this one's pretty easy to do because we said that the square root of x to an even power is simply dividing that power by 2, right? So the 5, I'm just going to rewrite it. 5 times, and what is the square root of x to the 8th? X to the 4th. Perfect. All right. Now, I need to work on this guy over here. I want to do the square root of 20, and I want to separate it with the square root of x squared. I separate the 20 and the x squared, and I apply the square root on each of them. Now, the square root of 20, I need to either do it on the calculator, or I could do it right here by hand. So 4 times 5 is the square root of 20. Split the root. That'll give you 2 square root of 5. And of course, that could be done on the Casio calculator. And the square root of x squared, what's that? That's a nice, beautiful x. Now keep in mind, you have this times this times this times that. It's all multiplication. So you could just rearrange it, put all the square roots together and all the nice numbers out in front. So my final answer is going to be a 5. An x to the what? I have an x to the 4th here and an x right there. When I multiply them, what do I get? X to the 5th. And we still have this 2 square root of 5. I messed up. Why did I mess up? Because the 2 and the 5 could also be multiplied. Final answer is 10 x to the 5th square root of 5. That's my final answer right there to this problem. And ladies and gentlemen, we are done with the practice final. Well, at least I'm done. You guys need to go back and review all the other ones and all the other videos.